Okay, so this is just a recap of the exercise we were talking about in the notebook. So can someone please give us just a resume of what we've seen last time in the exercise? What was it about and the steps? As you can see in the slide, it can help you.
We learn how to.
Hello.
Hello.
Okay, please
Uh,
go
we
ahead.
learn. We learn how to investigate a data set. Then we separate the information in training and validation.
Yes.
Um, we learn the shape of the set of uh, train and value.
Okay. What was the problem that we
We
were
want
trying
to
to solve?
learn how to recognize handwrite numbers.
Yes. What was the data set that we actually used?
The
You remember?
MNIST dataset.
Perfect. Yes, that's great. Okay, continue, please.
Um, and then we create the model. It's
Yes.
okay. And we were watching some level of accuracy of our model.
Mm-hmm. Yeah. Okay, so that's perfect. I guess this is a perfect recap of the exercise. Let's go over it step by step. So first of all, we loaded and visualized our data, the MNIST data. We edited our data to get into the right shape, as well as normalizing the value between 0 and 1. We also edited our answers to be in a categorical form instead of a number, as our model will better train with that type of answer. And we then created our model. We compiled our model and trained our model on the data. Okay, this is a photo of a picture of the in the dataset. So let's start with our data. We received each 28 pixel image as an array of 784 integers. Do you remember what is called this this actually operation of getting a vector instead of getting a 2D, a 1D vector from a 2D vector? I guess I mentioned that last time. Do you remember?
Normalization? Yes.
No, normalization is to have the data between 0 and 1. But here we had you remember when we had the matrix of the image?
Yeah, it
And
was
then
flattened. Right.
flatten, exactly, so it was flattened. So after now we have a vector of an array of 784 integers that we feed to our network. Okay, so we then normalize the data and then we encode the data. So we then took our answers or targets, which were in the format of an integer between 0 and 9, and made it categorical. Okay, so for example, we presented 0 as 1, 0, 0, 0, etc. We presented 1 and 0, 1, etc. So we represented an array of 0 with 1 at the index of the correct digit, etc. So this is how we encoded our target variables. And so we built our network I think we only used dense layers. Okay, so we built our input layer and the hidden layer and then the output layer. And if I have a question for you. So, what is the activation function that we've used in the output layer and why?
Softmax.
Yes, why?
Because it can classify, multi-classify,
Multi-classify.
like classify
Um,
in different number of classes instead of just two. No,
okay, okay. If we had a problem uh, with two binary classification, what do we use as an activation function?
It had to do with the probabilities.
Yes, exactly. So it has to do with the probabilities. So softmax actually had we have as an output the probability that this image is actually uh, in this class, for example, by 50% or 90%, etc. So it outputs the probability. But returning to your question, just a question because you said that in multi-classification, we used softmax, but when we have binary classification, just two classes, we cannot use softmax. That's what you were saying.
no.
Okay, because normally in binary classification, generally the best performance is of an activation function is sigmoid. We use sigmoid when we have a binary classification, and we use softmax when we have multi classification. Okay, so there are multiple activation functions that we can use. It depends on the case. Okay, so now returning to what we were talking about, our model, as you can see in the picture, uh, remember that we had 784 inputs, two layers of 512 neurons or nodes, and an output layer of 10 neurons, as you can see here. So one for each digit. So each the neuron is in each layer is connected to every neuron in the next layer, as you can see here. This is what the dense keras layer means. We have each neuron that is connected to the next layer. This means that there are a lot of connections. So if we have to actually calculate what are the number of connections in this model, how can we calculate this? Do you have any idea?
We can use relu or relu on the
No,
hidden layers. No.
no, I'm not talking about I'm not talking about the activation function. I'm talking about calculating the number of connections we have. So I mentioned here that we have 784 inputs. Okay, in the two layers we have 512 neurons or nodes, and we have in the output layer 10 neurons. So what are the number of connections we have in this model? We can calculate it simply by by 784 squaring it by 512 plus 512 um square 512 plus 512 square 10. Okay, this is the number of connections that
I'm
we can have.
sorry, I have a question. For example, each one of the 10 on the downside, they are connected to all of the 512.
Yes.
Oh, I see.
So every neuron in every
On one
layer.
layer is connected to the upper layer, to every node on the
Exactly.
upper. Okay, okay,
Exactly. That's what is the dense keras layer means. Perfect.
right.
Okay. So how many layers do we have in this neuron in this network? Sorry.
4.
4. Exactly. So we have a network for 4 layers. Okay. So I have another question. So if each neuron has a connection, as you said, between the other, okay, how do we store information? Do you have any idea?
Just in a matrix?
Mm, yeah, you're actually close. We store it actually in the weight between 2 neurons, okay? So this is how we store information in the model.
Okay.
Okay, so we're going to see uh, today the next chapter, which is machine learning overview. The exercise was just an introduction to deep learning and just to give you an idea how we can train the model and the different steps that we go through. But afterwards, we're going to see each step in detail. So I think it was just an early practice for you to go deeper. Okay, so in this today's chapter, we will introduce the main concept of machine learning, the classification of machine learning, the process of machine learning, and the common algorithms of machine learning. By the end of this course, you will be able to master the learning algorithm definition and the machine learning process. You will be able to learn some common machine learning algorithms and also to understand some key concepts like hyperparameters, gradient descent algorithm, and cross-validation. So this is a course that is a very long chapter. So we're going to divide it into 2 parts. We're going to see today the first part, and next session we're going to see the second part with a deep learning overview. Okay. Okay, so the content is going to go as follow. First of all, we're going to define machine learning. We already defined machine learning in the last session, in the first chapter. The types of machine learning, this is new. The machine learning process, some key methods of machine learning, some common algorithms that we can use in machine learning, and some case study. So we actually defined machine learning last time. Can you please give me just a small definition of the last session when we mentioned machine learning? Yes.
When we prepare a model to, for example, recognize something like a human, maybe the example of image classification.
Okay. Yeah. Perfect. So we actually we also defined deep learning and AI. I guess in the slide where we defined the three of them. So
That
here,
it
yes,
is a subfield of artificial
intelligence.
intelligence.
Yes. And the deep learning is a specific branch of machine learning. So if you have to understand the deep learning well, you should have a solid understanding of the basic principles of machine learning because deep learning is just a specific branch or a special branch in machine learning. So here we have the task T. As you can see, we have the data. Experience E, we have the learning algorithms, task T, and we have the basic understanding. So the learning algorithms is just how the machine learning system should process a sample. So what I mean by sample is just a collection of features that have been quantitatively measured from some objects or event that we want to the machine learning system to process. For example, classification, regression, as you mentioned, and machine translation. We also have the measure P. So the measure P is just how we evaluate or validate our model, okay? How we validate our machine learning algorithm. Can you give me some of the metrics we've seen in the exercise? How did we actually know that the model is doing well? There was a metric that we've used, true, I guess, true.
Accuracy.
Accuracy, and we have another one.
Loss.
Loss, exactly. So the loss and accuracy are in this the measure P, okay? And then the experience, which is the data. So most of machine learning algorithms, they need data to train on, and some algorithms actually needs the whole data, the entire data set, and some do not just experience a fixed data set. Okay, so for example, if we are talking about a specific kind of machine learning, which is reinforcement learning algorithms, this type of algorithms interacts with the environment. So there is always a feedback loop between the learning system and the training process. Okay. So we're going to see what is reinforcement learning. I'm going to give you an example just in a few. So this is just a comparison between how human actually process and how a machine can process. Okay. So if we take an example of an application of machine learning, let's say social media sites, they want to identify the people in their members' photographs. So this means not only detecting this means that not only detecting if there are any faces in a given photo, but we want to identify where those faces are located. And then we want to match up each face with previously seen faces. So this is um, even more difficult when we realize that virtually every photo of a person is unique because we have the lighting, we have challenges like the angle, the expression, the clothing, and many other qualities will be different from any previous photo. So your photo now, for example, if you're smiling, is not going to be the same as if you're sad or, for example, you're excited. Okay, so we would like to be able to take any photo of any person and correctly identify who it is. Okay, so this is just an example of an application of machine learning among many applications that we've seen last time. And because of their ability to extract meaningful information quickly, those applications or machine learning algorithms are finding their way into an expanded range of field and they become popular. Okay, so here they give you just a difference between machine learning algorithms and expert systems. Remember last time I mentioned expert systems? And we also mentioned the disadvantages of expert systems and why we were thinking about AI. Can you please remind me of what we've seen last time? What are expert systems?
I remember you said something about the long, the length of the code, maybe
The length
of the code,
the gold,
the code.
the code.
Yeah.
Yes, yes, that's one of the challenges or the inconvenient of using a traditional system.
Oh,
Yes.
right. Yes.
Perfect. Yes. So the essence idea of, or the most important idea of expert systems was that we would study what human experts know, what would they do, and how they do it, and we want to automate that. Okay. So in a sense, we'd make a computer system that could mimic the human experts it was based on. So this often meant creating a rule-based system where with mass a large number of rules for the computer to follow in order to imitate the human expert. So, for example, if we're trying to recognize digits in zip codes, we might have a rule that says that seven are shapes that have a mostly horizontal line near the top of the figure, and then a mostly diagonal line that starts at the right edge of the horizontal line and moves left and down. Okay. Can you picture seven as I described?
Yeah.
Perfect. So, for example, I can, for example, write seven with a bar. Okay. And this rule-based algorithm or this expert system won't be able to recognize my seven because it's different than the rules that it follows normally. So this is going to be an exception, and we should actually have new rules for this particular situation. Okay, so did you get the difficulty where it is?
Yes.
Okay, so the difficulty of just manually crafting the right set of rules and making sure they work properly across a wide variety of data has spilled their doom as a general solution. So, just the fact that we have to articulate every step in a complicated process is extremely difficult. And when we have to factor in human judgment based on experience and hunches, it becomes nearly impossible to for any but the simplest scenarios. So this is the beauty of machine learning where it shines, is that they learn a dataset's relevant characteristic automatically. So we don't have to tell an algorithm how to recognize a 2 or a 7 because the system figures that out for itself. But to do that well, the system needs, of course, a lot of data, a large amounts of data, and that's a big reason why machine learning has exploded in popularity and applications in the last few years. So I hope now you can make the difference between machine learning algorithm and you can see the importance of machine learning algorithms vs the rule-based algorithms or traditional way. Can you see it now?
Yes. Yes.
Okay. Okay, so this is just some application scenario of machine learning. Okay, rational understanding of machine learning algorithms. Okay, so here they explain to you a little bit about how the process of machine learning algorithms. So as you can see here, we have the target equation. We have x, and we want to predict fx or y. Okay, so this is actually the training data, and we choose our learning algorithm, and we have a hypothesis function, which is g. So the target function f is actually unknown. So we actually want the objective of machine learning algorithm is to approximate a function called g, because we cannot have a perfect function f. We want to just do an approximation of the function f and have a great result. So have a result that is ideal. Okay, so this is this is the basic of machine learning algorithms, how it works. Now, Okay, I will jump to this because I think this is just the types here. Okay, so there are multiple types of machine learning where we talk about supervised learning. So in this particular type, we give a computer a bunch of choice questions or training samples, okay? And we provide a standard answers. So we will like a teachers. We give you, for example, the data, and we give you the right answer of the data. So the question and the answer, okay? And the computer, it tries to just adjust its model parameters to make their prediction close to the answers that were given in the first place. Okay, so in this way, the computer just learns how to deal with this type of problem. Then the computer can help us reply to choice questions whose answers are not given, which are the test samples that we divide in the first place. So there are actually two general types of supervised learning. We have classification and we have regression. Classification is concerned with looking through a given collection of categories to find the one that best describes a particular input. For example, classification of a dog and a cat. So this is a problem in classification. And we can have a regression. So regression is when we have a problem when we have to predict another value, okay? Based on a set of measurement, we want to predict some other value. So this is a regression. Can you give me an example of regression based on the definition that I've sent you?
It could be uh, the weather. If it
Yeah,
is, if the sky is gray, if it is cloudy, and if it is cold, then probably it will rain.
perfect. So based on, for example, some measures like I'll give you, for example, based on the height and uh, uh, let's say the gender, we can actually predict the age, for example. So this is just an example, and the perfect example you mentioned of the weather, based on the wind speed and the temperature, we can predict the weather. So this is another this is a great example of regression. Okay, so the example of classification, there are multiple examples. Suppose we have a collection of photos of everyday objects and we want to sort them by what they show. So an apple peeler, a piano, and so on. We say that we want to classify or categorize these photos. So the process is called classification. And in this approach, we start training by providing the computer with a list of the labels or the list of classes, okay, that we want it to learn. And this list typically is just the combination of all the labels for all the samples in the training set. But remember that we have duplicated, okay, duplicated labels. So we have to remove the duplication, and we then train the system or the model with a lot of photos and their labels until we determine that is doing a good enough job of predicting the correct label for each photo. Now we can turn the system, we can try it on your photos it hasn't seen before, and we can see the results. Okay, so I think the classification is clear. So now let's move on to unsupervised learning. Unsupervised learning is when our input data does not come with the labels. So remember when we were talking about supervised learning, we said that we give the input data and the labels. Now unsupervised learning is actually the opposite. We give the input data but without labels. So we say any algorithm that learns from data comes from the category of unsupervised learning. Okay, so this just means that we are not teaching, or we are not teaching the model, we are not supervising the learning process by offering labels. The system has to figure everything out on its own with no help from us. So this is what is unsupervised learning. We use it often to solve problems that we call clustering, for example. So clustering is unsupervised learning. Okay, so the third type is semi-supervised learning. It's actually a mix between the supervised learning and unsupervised learning. So we here in this type, we have, for example, a small amounts of data that we label, and other data that we don't label. So we have a mix of both worlds. And the last one, okay, I'm going to, okay. And then we have the last one, which is reinforcement learning. So reinforcement learning is actually different than supervised learning and unsupervised learning, the three types that we've seen before. So reinforcement learning is that here the model take action, and after that we're going to tell to the model, yes, this is right, no, this is wrong. Okay, so we're actually doing the supervising after. Okay, so it's not before. If it's before, then we're talking about supervised learning. If it's after the action, then we're talking about reinforcement learning. Okay, is it clear? Do you have any question about this part?
No questions.
Okay, accept someone. Okay. Okay. Do you have any questions?
No.
Okay.
No, it's clear.
Okay. So this is an example of supervised learning. So we start by, first of all, we start by collecting the facts we're going to teach. And we do this by collecting as much data as we need, for example. And after that, we each piece of observed data, say for example the weather at in a given moment, is called a sample, and the names of the measurement that make it up, the temperature, the wind speed, humidity, etc., uh, are what we call features. Okay, so this is just a terminology that you should be used to. So now we defined what is a sample. Now we are defining what are features. So as you can see here in the example, the weather.
Sorry,
Yes.
sorry for interrupt. I think you are not sharing your screen.
Yes, it just
I
changed.
Okay.
Yes,
Okay.
we
stop.
cannot see your screen.
Now can you see it?
Yes. Yes. No, we can.
Okay. Okay. So I was saying that we defined what is a sample, and we now we're defining the features, I guess. So I was talking about the features. So the features are here: the temperature, the wind speed, the humidity. These are the features. Okay, so each named measurement that I've talked about now, or feature, has an associated value. Typically we store it as a number. Okay, so for example, if we say here yes, no, and yes, remember when we were feeding the data into the model, we had to encode it. Okay, so for example, yes is going to be 1 and no is going to be 0. And this type of encoding, we call it hot encoding. You can search about it later. But now talking about supervised learning, to prepare our data for the computer, we hand each sample, that is each piece of data with a value for each feature, to a human expert who actually examine its features and provides a label for that sample. And for instance, if our sample is a photo, the label might be the name of the person in the photo, or the type of animal it shows, or whether or not the traffic in the photo is flowing smoothly or it's stuck. So once we have our labeled data, we give it to our computer and we tell it to find a way to come up with the right label for each input. Okay, so we do not tell it how to do this. Instead, we give it an algorithm with a large number of parameters it can adjust. So perhaps even millions of them. So once we've, for example, there are multiple algorithms that we can choose. Once we've selected an algorithm, we can run an input through it to produce an output, which is the computer's prediction of what it thinks, for example, the expert's label is for that image. So when the computer's prediction matches the expert's label, we won't change that. We won't change anything, okay, about architecture. But when the computer gets it wrong, we ask the computer to modify the internal parameters for the algorithm it's using so that it's more likely to predict the right answer if we show it this piece of data again. Okay, so the process is basically trial and error. So the computer does its best to give us the right answer, and when it fails, there's a procedure it can follow to help it change and improve. So we only check the computer's prediction against the expert's label once the prediction has been made. So when they don't match, we calculate an error that we call cost or loss, okay, loss function or the loss. So this is a number that tells the algorithm how far off it was, and the system uses the current values of its internal parameters, the expert's prediction, which is now knows, and its own incorrect prediction to adjust the parameters in the algorithm. So that is more likely to predict the correct label if it sees this sample again. Okay. So later on, we're going to look closely at how these steps are performed, but just bear in mind that uh, that in the for now, just it's worth knowing that each algorithm learns by changing the internal parameters it uses to create its prediction. So it can change them by a lot after each incorrect sample, but then it runs the risk of changing them, so it makes other prediction worse. Okay, so it could change them by a small amount, but that could also cause the learning to run slower than it otherwise might. Okay, so the right trade-off or the right percentage to change between these extremes is something we have to find by trial and error for each type of algorithm and each data set we're training it on. And what we call the amount of updating we do, the learning rate. So a small learning rate is cautious and slow, while a large learning rate speeds things up but could backfire. Okay, so we're going to see these terms in detail, but will just give you an example, just a general view on what's coming next. Okay, so did you get the steps that I was explaining? Do you have any questions?
No.
Okay, so all is clear?
Yes.
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 Okay. Okay, so this is a regression example. So for example, what's the temperature on Tuesday? So we're trying to predict the temperature of Tuesday based on the temperature, for example, of Monday, or some other features. Okay, so this is a regression example. Classification example, which method is more attractive to customer, A or B? Okay, which, for example, I don't know why I thought of fruits, but which fruit is more okay? I say I wouldn't say more healthier, but I would say it's more beneficial. For example, um, in vitamin C or etc. So E or C or B. Okay, so these are some examples of classification. Now, unsupervised learning. Here, can you give me the definition of unsupervised learning that I've mentioned just a few minutes ago?
It's
We
the one that
group,
don't
sorry,
have labels. No, go
Yes.
ahead, go ahead. The one that doesn't have labels.
Yes. So the one that doesn't have labels.
we group the information in base of a number. For example, we create a cluster and we classify the information if it's near between them.
Okay, so based on what we classify, for example, if we're talking about clustering, based on what we're going to, for example, classify those two people into that group and the other person in the other group.
It can be maybe an example for a qualification of an exam.
Mm, not really. How can you classify two people in the same group? What should be your measure to actually classify those two clients, for example, as the same type of clients, if we're talking about marketing?
I think it could be based on their similarities or what they share in
Exactly.
common.
Yes, I was actually looking for the word similarity. So based on the similarity, we're going to classify those people as are similar. So they're going to be in the same group. Okay. For example, similar in their purchasing. So habits in their purchasing habits, or similar in the um for example, loving both football or loving both basketball, etc. So this is actually the how the unsupervised learning algorithm is based on. It is based on similarity. So here they give you an example of clustering, and the questions they said, for example, which audience like to watch movies of the same subject. So those audience that, for example, likes to watch movies or horror movies, are going to be in the same group, and those that like to watch comedy movies are going to be in another group. So this is how we actually classify the samples in a data set. It's based on similarity. Now, what is supervised learning?
Mixture of the supervised and unsupervised learning.
Yes, so we have a small data that we label, and we have other data that we don't label actually. So, for example, here they labeled the first line, the first row, sunny, warm, and strong, and they said enjoy sport, yes. So this is actually labeled, and then we have two rows that are actually unlabeled. Okay. Now let's move on. Reinforcement learning. So can you give me a definition of your reinforcement learning?
It's
We do it after the supervision, supervised learning.
Yes, in what sense? Can you give me an example so you can, I don't know, I think
Yes,
you got the definition that I gave you, but I want to actually know if you actually understand it.
yes, the reinforcement learning, classifying well or wrong the
Yeah.
supervising learning. It's okay.
No. So classify wrong or right what? The action taken by the model. Okay, I'll give you an example so you can actually have a clear idea on what is reinforcement learning. So suppose for example a bachelor, okay, with no children has to suddenly step in to take care of a friend's 3 years old daughter, okay? So he has no idea what the baby likes to eat. Their first night together, he aims for simplicity, so he makes pasta with butter for the kid. Okay, so she likes it. But after pasta with butter every night for a week, the man and the child are both starting to get bored by the same old thing. So the man adds some cheese, and she likes that too. Okay, so eventually, alternating pasta with butter and cheese starts to get boring again. So so one night the man uses pesto sauce, okay? But his friend's daughter refused to take the bite. Okay, so the baby or the kid refuses to take a bite with the sauce. So he makes a new batch of pasta and tries, for example, marinara sauce, another type of sauce instead. And also, she rejects that too. She doesn't want to eat that too. So, frustrated with variant on pasta, the man will give up and tries making her a baked potato with sour cream. And so it goes, and so as it goes, our new cook trying one recipe and one variation after another. So he's trying to develop a menu that the child will enjoy. Okay, so the only feedback he gets is that either his the baby or the kid eats the meal or she doesn't. So this approach is called reinforcement learning. Okay, so we can actually rephrase our cooking story above in more general terms by renaming the chef as the agent, okay, and the child as the environment. So the agent is the thing that is making decisions and taking actions. So that's the chef, and we have the environment is everything else in the universe. That's the child. So the environment or the child gives the agent, the chef, feedback or a reward signal after each action. This is how the chef can see if the action that he is taking is good or bad. Okay, so based on the evaluation of the action or based on the feedback, the chef is going to change the environment. Okay, so I think this is a clear example for you to just understand what's the concept of reinforcement learning. I hope um, you get the meaning. Is it clear?
Yes, it's
yes.
very clear.
Okay,
Yes,
so
very clear.
this is reinforcement learning. Okay, reinforcement learning the best behavior, as they said. So we always look for best behaviors. Um, and yeah, so we're trying to base our decision based on the feedback we're getting. So now we're going to see the machine learning process. So this is the machine learning process or the machine learning. If we are trying to manage a machine learning project, these are the steps that we're going to do in order to have to do the management of our project. So first of all, we have to collect the data. So data collection, I think the majority of the time we spend more than 80% of the time just for in this part of data collection and data cleaning, because sometimes there are problems or projects that don't have enough data, for example, or that needs a private data. I recently was working on shake banks, shake banks handwritten recognition. Okay, and as you know, the bank check is actually a private data to actually for a person to give. Um, so it was challenging. So I think the part of data collection and data cleaning is the most challenging part in the process of machine learning. And data cleaning, because we can have a lot of data but not cleaned. So there are multiple duplicated values. We can have, for example, wrong data. We can have missing values. We can have um, just some noise that can actually disturb the machine learning process. Okay, and we have to do our best to eliminate the maximum in this step in order to have a proper model, okay, machine learning model. And then we have the feature extraction and selection. So as we mentioned before, the features, for example, we have features and we have the target variable. Okay, so we have to extract the features, and in order to extract features, we can have, for example, in an Excel file, millions, even billions of features. So how are we going to actually select the most important features? So there are multiple methods that we have to use in order to select just the most valuable, the most features that have the most information that's going to help us predict the target variable. Okay, and then we have the model training. So I guess that's clear. We've seen this in the notebook. We compile the model and we train it. And after that, we have the model evaluation. So the model evaluation based on the test set that the model never seen, and then we deploy the model, or we integrate the model. We can integrate it, for example, convert it to a TF Lite and use it on our mobile phone. We can deploy the model on the cloud, edge cloud, public cloud, private cloud, etc. So these are the steps of the machine learning process. And as you can see, it's not an iterative process. Okay, not like computer software development management projects, because in software we have tasks. Okay, and we after we finish the task, now it's done, we can actually use an agile method, for example Scrum. Okay, but here in machine learning process, we can go from model evaluation and we test the model, we see that it has bad results or poor performance, and we had to go back to the data cleaning because, for example, we forget to clean some of the data, um, or maybe we cleaned it in the wrong way. Okay, so for example, if we have missing values and we actually dropped all the rows with the missing values, and we conclude that we don't have to, there are many techniques that we can use otherwise. So we go again to the data cleaning, we do the test and see if the model evaluation will increase. Okay, so it's a back and forth process. So we don't jump completely from a step to another step. Okay. Okay, so I can accept someone. Great. Okay, so perfect. Now let's talk about some basic concepts of machine learning. I think we'll take a 10 minutes break before we continue. Is that okay?
Yes, okay.
Yes, thank you.
Okay.
Thank you.
Okay.
Thank you.
You're welcome. So after 10 minutes, we're going to start. Okay?
Okay.